In the last video, we concluded by stating that the left side was the more complicated side of the equation. Because our final answer, when we simplify the left side, should reduce down to plain old sine x, we need to look at what we were given. In this case, the easiest way to start the problem is probably going to be to FOIL, or distribute, the terms. Notice my second term. When I multiplied cosecant x times cosine x, since I couldn't combine them in any way, I just wrote them next to each other. It would be like multiplying a times b and writing ab as the term. Looking at where I'm going, I need everything in terms of sine. I see cosines in here. My next step then is to convert everything into sine and cosine language. See if I can reduce or cancel and start breaking things down. You may want to note, this is my first term, cosecant. This is my second term. It's cosecant times cosine. I've changed the form of cosecant. This is my third term, which is cotangent. And my fourth term is a combination of cotangent times cosine, cotangent rewritten in a different form. When I multiply through each of the terms, this is what I'm left with. Notice in the middle, negative cosine x plus cosine x. If I added those two things together, they would cancel to 0. I can cross those two terms out. What I'm left with has the same denominator. When we add or subtract, we have to have the same denominator. We already have the LCD of sine x. Simply rewrite as a single fraction. Now once again, look at what I have, look at where we need to go. I need to get rid of that cosine squared. Light bulb should go off. 1 minus cosine squared x is the same thing as sine squared x from the Pythagorean identities. I then can reduce the sine squared divided by sine, and my final answer is, in fact, sine x. Example 2. Obviously, the left-hand side is much more complicated. We do not want to cross-multiply. The directions, when we look back through the steps, say to choose one side and work with each side separately. When I look at the left side, I recognize that I have to turn everything into cosecants in one, so the cotangent squared does not belong. For me to take this into sines and cosines, or 1 over tangent squared, isn't going to help me. However, there is a Pythagorean identity that relates cotangent back to cosecant. If I rearrange the equation, I can substitute out the cotangent squared x, and then factor the numerator. When I factor the numerator, I then can cancel the terms that are the same, and notice that what I'm left with is what I started with. Example 3. The left side is much more complicated. Not only do we have a fraction involved, but we have 3 different ratios. None of them involve squared, so we can't go to Pythagorean identities. We're today going to talk about a new algebra technique. Remember when we add fractions, we have a common denominator? Well, we can split a fraction. I'm sure it sounds painful. However, by splitting a fraction, we may be able to reduce each part of that split in order to come up with our answer. By splitting the fraction, do you notice the second term? Cosine over sine is the same thing as cotangent. It looks like we're on the right path. The question is, how is the first term going to simplify to secant t? By substituting everything into sines and cosines, We then have a fraction divided by a fraction, which we can then take the numerator times the reciprocal of the denominator, cancel, then rewrite using our definitions into secant t plus cotangent t. In the You Try section, I challenge you to pause the video and try this one on your own based on Lesson 1 and Lesson 2 algebra techniques. I gave you a hint telling you that you will need to use the LCD. I think it's obvious the left side is much more complicated than the right side. At this time, I would pause and try this out, at least for the first line or two of work to make sure you're on the right track. By showing all of the work, I'm going to multiply the first fraction by sine over sine, and the second fraction by 1 plus cosine over 1 plus cosine. Notice I get sine squared theta, first numerator. In my second numerator, I'm getting cosine plus cosine squared theta. Now, most of you are familiar with distributing. It says to do LCD, I'm going to multiply through. However, let's take a second and look at the other side, where it is that we're going to end up. Cosecant has another definition. It's 1 over sine. If I look here, don't both of my fractions have sine in the denominator? That seems like it should stay there, considering cosecant is 1 over sine. My next step, since I have the same denominator, even though it's in factored form, is to create one fraction. Now, at this point, please notice I have a sine squared and a cosine squared. If I rearrange the numerator, notice these two together can come out, and I can replace it with a positive 1, which is the Pythagorean identity. These two terms were replaced with a positive 1. How does that help me? Well, notice, now I have two terms in the top that are the same as the parenthesis group in the denominator. I can cancel those. Please do not make the mistake. There is a 1 left in the numerator when I cancel. 1 over sine is the same thing as cosecant, which is what I was trying to solve to find. Please pause the video and complete numbers 1 through 5 from the verifying identities.